Now let's activate the UTM grid and get to know that system. So under View, Grid. So we see Maine is completely within zone 19T. Let's scroll in here and you see as I do, we have zone 19T, we have an easting and a northing value. The easting is the distance in meters from a sort of imaginary center line, and the northing is the distance in meters north of the equator. I've drawn the center line so you can see how it works. I'm going to check that on now. That red line is UTM easting 500,000. If I move the cursor to the east, see how those numbers go up. If I move it to the west, the numbers are going down. When it's right on top of it, that is exactly UTM easting 500,000. Now remember, our UTM northing is the distance in meters north of the equator for us. So if you look at the northing value now, the northing is 15.24. As we get closer to this line, you'll see it approaches 0 until we get to that place marked there. And we have 0.13, and then we're into the southern zone. So let's use our measuring tool to confirm some things. So right here on this southern point, 0.13 meters, we're going to have to call that close enough. Click again until it hears me. Thank you. So now, as I move this cursor, there's a little bit of measurement area you see here. But as I move along, you can see that this distance in meters that I measure matches that coordinate. So the UTM system is a pair of coordinates where the northing value is the distance north of the equator and the easting value is the distance from this imaginary center line. Both lines, of course, imaginary, but well, unless you happen to go down there and find a line. If we go all the way down to the Brazilian rainforest, we can see this UTM northing value approach 0 as we approach the equator. And then when we pass over the equator, it goes to 9999999 south. We're into the southern zone. We don't have to worry about that. We're always measuring northing as meters north of the equator. So in the UTM system, every point, every location on the map is defined as a distance north of the equator and east or west of this imaginary center line, which is defined as 500,000. Now looking down from the North Pole, we can see that our UTM Zone 19 North is one of 60. It's actually one of 120 because there's 60 southern zones as well. But this gets around a lot of the issues with global map projection. So you're trying to take a world that's not even quite round and display that on a flat surface. So you're going to lose either area or shape or direction when you do that. But when you split this into 60 parts, you only have to worry about this little slice of it, and it makes it a whole lot easier to take this surface, which is something not quite round, and put it down on a flat map and use a Cartesian coordinate system, which is x and y, or easting and northing. So every one of these zones has its own central meridian. We have this red line going down the middle of Zone 19 North, but if we were learning over here in Zone 18, we'd have a red line going down the middle, and that would also be 500,000. 17 has a line 500,000. All those coordinates, all those easting values are measured off of its imaginary line, or its central meridian. So you can go from one zone into the next using that same central meridian. You lose a little bit of accuracy the farther you go, and a lot bit of accuracy once you get pretty far away. When we load something up in the UTM coordinate system in GIS, you'll see that it will allow you to display a couple of zones in either direction, but it'll just turn the map black, so it doesn't give you the idea that you're having any kind of accuracy outside of your zone.